Okay, the next notion is the notion of an inflection point, sometimes called points of inflection. So inflection points or points of inflection. An inflection point is where the curve changes concavity. So if there is a point on the curve where it changes concavity. So if we have a curve that does this, here it's concave up, here it's concave down, which means somewhere here it must have changed concavity. That value, where it changes concavity, is called an inflection point. So an inflection point is where the curve changes concavity. The inflection point occurs at A, comma, f of A. Whatever that value A happens to be, whatever that value happens to be, the coordinates of that point are A, comma, f of A, an inflection point. This is changed from concave up to concave down. Similarly, if a curve changes from concave down to concave up, it must have changed. Here's concave down, here's concave up. This is an inflection point at A, comma, f of A. All right? Now, in this interval, the curve is concave up. The second derivative is bigger than 0. In this interval, the curve is concave down. The second derivative is less than 0. Well, if it's greater than 0 here and less than 0 here, it must have changed at this point. That's where the second derivative is equal to 0. So the change of concavity, the inflection point in this circumstance, the inflection point occurs when the second derivative is equal to 0. Similarly, here is concave down, it's concave up. The second derivative is negative, the second derivative is positive. At that point, the second derivative is equal to 0. So, if the second derivative is equal to 0, that is a potential inflection point. If you have an inflection point, that occurs because the second derivative was equal to 0 in this scenario. It can also occur where the second derivative is undefined. Remember, the derivative might be undefined at a cusp. So let's suppose we have a curve that is concave down, comes to a cusp, and then leaves as concave up. So here it's concave down, here it's concave up. This is an inflection point at A, comma, f of A. But this is because the second derivative does not exist. And so we have the same kind of thing as we had for the first derivative. A relative extremum occurs if the first derivative is equal to 0 or if the first derivative does not exist. A relative extremum might exist. Well, there might be there is a potential inflection point if the second derivative is equal to 0 or if the second derivative does not exist. Now, if we know the curve is changed, then we know that we have potential inflection points. So I've left up here the last piece of the problem we did on the previous video. Notice that in this interval, from negative infinity to 2, the curve is concave up. From negative 2 to 2, the curve is concave down. There is a potential inflection point at x equals negative 2. So we would say there is an inflection point at, we need negative 2 comma number. And then is it clear it was concave down, it changes to concave up. There is potentially an inflection point at 2 comma number. We don't know what that coordinate is. Well, what do we say? A comma f of A comma f of A. Not f prime, not f double prime, f of A. So if we need to find the point on the graph, we need to use the original function. So the last piece of this the last piece of this second derivative analysis is to compute f at these change values where it changes, these cut values where the concavity is changed. So the original function, we need f of negative 2 and we need f of positive 2 to evaluate the function. The example we had was, I'm going to run out of space here, our original function, if you recall from the previous example, was x to the fourth minus 24x squared plus 2, I believe it was. And so, up to the fourth. And so we evaluate f at -2 and f at +2 to determine those values. In this case, this is -2 to the fourth minus 24 times 2 to the second rather, plus 2. So how much is that? I don't have a calculator with me. So that is 16 minus, I need 24 times 4, that's 96, plus 2, which is -80 plus 2, which is -78. So there is an inflection point at, I'm running out of space here, at -2 comma -78. And then if we evaluate +2, it's not particularly challenging to see that if this is +2, this is still going to be 16. This is still going to be 96. This is still going to be -78. And so either by working it by hand, or you can use a calculator if you prefer, this is also at -78. So there are two inflection points, one at -2 comma -78, one at 2 comma -78.